Hello and welcome back. First and foremost, I apologize profusely for the excessive delay in getting something out to you all. I had it in my mind that I would finally circle back to the Collision series and finish it off with the Contact Resolver. However, from about the time the last video came out, I've been working on the more behind the scenes code, and I realized that I was giving up a great opportunity to share that progress and development with you all. Up until now, my primary focus has been on the framework side of video games, and not so much on the game engine or the actual game itself. With the exception of the graphics, the framework is beyond mature enough to realistically be used in a game environment. And with that, my focus has shifted away from the framework and towards actual games, and subsequently the engine that will run said game. Currently, the way I visualize the project is like this. We have a framework as a container for a bunch of sub-engines. These sub-engines each run in their own thread and target a specific purpose. Currently, Manifest uses three separate threads, one that manages the main thread and physics simulation. There's a thread that controls rendering and manages the context. And there's one final thread that handles the AI planning simulation. Some of these sub-engines output specific state that is required by another sub-engine. In order for this communication to happen, the sub-engines communicate indirectly with one another in one of two ways. For communication that cannot be missed, there is a messaging pipeline that uses a version of the observer pattern to route specific events that happen in an event space. An example of this type of message would be an object needing registration into the AI system after being instantiated on the main thread using the HiveMind event space. The next way to communicate is through the runtime database. The database is used when you don't particularly care about the most up-to-date data, but simply the existence of data fields. An example of this type of communication would be the renderer reading the world states and object IDs from the simulation and then using those transforms on the corresponding graphics objects that belong to the simulated object IDs. I have videos about both of these that I will link below. The code is a little outdated, but I've made sure to show the most up-to-date version here in the video. However, the core concepts behind the communication library still hold true. While this is just a broad overview that skips the more nuanced decisions and the details lost in the minutiae, the overall architecture has served me very well, and for the foreseeable future, I don't see this changing much. Not to mean the sub-engines themselves won't be updated, but the core layout should remain. So now this leaves me with a fairly solid foundation to build on, but I'm also left with the question, how do we make a video game? Not only technologically, but also as an experience. Currently, anyone's guess is as good as mine, if not better, about creating a fun gaming experience. However, the process of building the game, at least at a high level, has been the guiding architectural philosophy behind the framework's development. I am of the opinion that a video game should be two components: an executable that hosts the specific non-serializable elements of the video game, and the second component is a binary or collection of binaries that contain all the serializable elements. The execution of the game would simply be spinning until close in the game executable and loading data off the binary as dictated by the game's engine. To illustrate this a little more clearly, this is the example that stuck with me when I first came up with this notion. If you played WoW before, you'll already know this, but for those of you who don't, in this game, the area which you begin changes depending on the race you choose when making your character. The beginning zones are each modeled in a very similar manner: renamed quests, reskinned enemies, NPCs, etc. Each starter zone is one and the same with a different theme. Imagine now if we isolated the game to be just these starter zones and exported all the zone data into binary databases. Using the same WoW engine, you would be able to run each as its own individual game. There's definitely a discussion to be had as to whether or not you need an independent framework to support said engine, but not one that should be had today. Nonetheless, now that we've established some foreground, let's move on to the main topic of today, architecting a game engine. The game class itself serves as the entry point and provides access to the framework. As mentioned previously, the game spins in its own update loop until close. This exists at the highest level of the runtime. From this point, the structure becomes remarkably similar to the framework. The game is supported by a series of modules which, like sub-engines, handle their own designated groups of tasks. The main difference here is each module runs sequentially on the main thread inside of the game update loop. In order for the modules to communicate, I use a very similar design to the runtime database called the signal bus. Without going into too many details about it, the signal bus works by modules sending a signal to the bus, and the bus routes it to any receiver registered to that signal. The receivers can then optionally send back a result signal to the original sender should one be needed. Next, we cross over into a liminal space where the runtime meets the build time. A system of importers and exporters are implemented over the game and framework UDTs. These handle the serialization tasks of both building and running the game. On the build side, the exporters are implemented by database builders. The builders are likewise an interface over a UDT and passes that type to its own exporter member. The primary function the builder serves is to handle the creation, modification, and removal of game object entries into their respective manifest binary database. And this brings us to the absolute heart of the engine, the one big beautiful binary. Existing in what I can describe as epic time, as redundant as that sounds, this mega binary file is a collection of binary databases, a database of databases essentially. From here, a game can either be built or edited using the build tool. Not only that, but a new or saved game can be loaded on the other end of the spectrum during the runtime. Finally, we add access to the game modules to give them the responsibility of importing and exporting assets inside of the binary file on demand. And with that, we have the first and most certainly not final design of the Manifest game engine. Thank you all so very much for your time. I hope you found this interesting. Given all of the changes behind the scenes that have taken place to bring my architectural philosophy to fruition, I have a plethora of new technology I'm incredibly excited to share with you all in the future. But until then, I hope you have a great rest of your day, and I will see you in the next one.